So this is going to be a video dealing with applications. I'm going to do several of these videos separately. Let's look at example number 1 first. We'll read through the question. So you have a piece of machinery that produces rectangular sheets of metal. So this is the picture that you see on the left. This sheet of metal has the length twice the width, and you can tell that by what they've given you here on the picture. Equal size squares measuring 10 centimeters on a side are going to be cut from the corners. So what they're talking about is a 10 by 10 square is going to be cut on every single corner. And the reason that they're going to do that is so that the resulting piece of metal can be shaped into an open box by folding up what's left. And that's what you see over here on the right side picture. If the specifications call for the volume of the box to be 7,500 cubic centimeters, find the dimensions of the original piece of metal. So you notice here that I've written down the formula for volume of a rectangular box. So this is going to be the length times the width times the height. And so the first thing that we want to do is just simply set up an equation. So we've got our volume is going to be equal to the length of the box times the width of the box times the height of the box. So that's where I got those values. And then we'll go ahead and multiply those together. I didn't show all of my steps in multiplying, but if you'll take the time to FOIL out and distribute, this is what you'll get. Now I'm ready to take what they gave me, this 7,500 cubic centimeters, and now I'm ready to plug that in for the volume. And this is just a quadratic, like what we covered in section 1.4. So we'll go ahead and solve the quadratic like we are used to solving. So the first thing I'll do is move that 7,500 over to the right-hand side. Personally, I look at this and I see that there is a GCF of 20. So that the next thing that I did was I factored out a 20. Now at this point, you can do a couple different things. I didn't show this, but I could have divided on both sides by 20. And because on the left side, 0 divided by 20 is 0, then that 20 would have gone away. I kept it where it was, but you could do that if you would like. I proceeded to go ahead and factor my trinomial. And since this is nicely factorable, then I'm going to use the zero factor property and set each piece equal to 0. Of course, we understand that 0 is never going to equal 20, so we can throw that part out. Like I mentioned earlier, you can get rid of it earlier, or you can wait until this point and get rid of it. And then I'm going to solve my little mini equations so that x is equal to 35 or x is equal to -5. Now let's make this make sense. Let's go back to the original question, and it said to find the dimensions of the original piece of metal. Find the dimensions of the original piece of metal. Well, we understand that there is no way in the world my original piece of metal can have a side length of -5. So this particular solution, we're going to throw it out because it's not possible. And so we'll use x equals 35 as one of my solutions there. But this says to find the dimensions. So not only is this going to be an x value of 35, but if we double that, we'll get an x value, a 2x value of 70. Of course, these were measured in centimeters to begin with, so then the sheet metal is going to be a 35 centimeter by 70 centimeter sheet of metal.